Hi everyone, welcome back to my YouTube channel. In today's video, I am going to discuss one of the important topic, that is parameters of bridge rectifier. In the previous video, I already uploaded a working and construction of the bridge rectifier. If you want that video means, I will definitely pin that video in my description. So first go and watch that video, then you can understand the parameters of the bridge rectifier very easily. And coming to this video, what is the importance of finding the parameters and how their parameters are useful. In this session, we will mainly discuss the average value, that means the average current and average voltage of the bridge rectifier. So now, what is the importance of finding the average value and how it is used? Means the first and most important thing is, by using the bridge rectifier, we are converting the alternating voltage into the DC, means pulsating DC. So by converting this, the electronics applications will be work. So to convert this means, by converting the AC to DC, how much the DC will be obtained in the output. So to find out that, we are finding the average value. I am repeating this once again. So what is the purpose of finding the average value means, when we are converting from the AC to DC, how much amount of DC is obtained in the output. So for that purpose, we are calculating the average value. Now we will derive the derivation for the average value. See, the average value can be found out by using the sum formula, and this average value is also called as the DC value of the current and DC value of the voltage. The formula is area of one cycle of curve by base. So by using this formula, we can going to find out the average value of both the current and voltage. Now to find out the area of one cycle of the curve, we have to use the waveforms of the bridge rectifier. So we know the waveforms for the bridge rectifier. In the input signal is, that is the complete sine wave, and from the input the output is upward. The bridge rectifier which is converting the AC to DC by using the 4 diodes which are constructed in the form of bridge. So from the output is occurring both positive half cycle as well as the negative half cycle. So the time period is from the 0 pi, 2 pi, 3 pi and 4 pi. So now from the formula, they given that area of one cycle of the curve means one, we have to consider one complete cycle, that is from 0 to 2 pi. Means integral 0 to 2 pi. So we are finding the current value ID omega t. So now, ID omega t, and what is the base? Base is 2 pi. So now here the 2 pi is constant, right? So bring that 2 pi outside. Then what we get? Integral 0 to 2 pi ID omega t. Now split the integrals from the 0 to pi ID omega t plus from the pi to 2 pi ID omega t. So now the value of I, as we know, I is equal to Im sin omega t. So from the 0 to pi, it will means the waveform is occurred from the 0 to pi. The value of I is Im sin omega t. Substitute the I value in the equation, that is 1 by 2 pi into integral 0 to pi Im sin omega t plus, and now from the pi to 2 pi. So from the pi to 2 pi also it is conducted. The Im sin omega t dt. Here Im sin omega t plus Im sin omega t, we can consider that 2 Im sin omega t. Integral 0 to pi 2 Im sin omega t dt. And now here 2 Im is the constant terms. To bring the 2 I, so Im by sin omega t dt. So by bring the 2 Im outside, that is 2 Im by 2 pi into integral 0 to pi sin omega t dt. As we know, the here 2 will get cancelled, and we know the value for integral sin omega t. So that is minus cos of sin omega t, and limits are from the 0 to pi. So substitute the limit in cos omega t. That is Im by pi into minus of cos pi minus into cos 0. So as we know, the value for cos pi is equal to minus 1, cos 0 is equal to 1. Substitute that values. Im by pi minus cos pi value is minus 1, minus cos 0 is 1. So minus 1 into minus 1, that is minus 2, and here minus into minus plus Im by pi into 2. So that is 2 Im by pi. So this is the average value for bridge rectifier. So same yeah, so in same way we can find out the average value for voltage also. So IDC is equal to 2 Im by pi. This is for the current, and VDC is equal to 2 Vm by pi. This is for the. So I hope you understand the calculation for the average value of the bridge rectifier. Thank you for watching, and don't forget to subscribe my YouTube channel and like, share this video with your friends. See you in the next one.